In this section, we will be talking about how we calculate a confidence interval when we do not have a large sample. That is, when our sample size is smaller than 30 data items. And so what can we do when our sample has fewer than 30 data items, which happens sometimes because getting data can sometimes be very difficult? Well, we can use a smaller sample if our original random variable x is normally distributed. So if we start out knowing that our original random variable is normally distributed, then we can find confidence intervals again. Now we'll discuss in a future lecture how to determine whether we can treat our data whether or not it's as a normal distribution. The main difference in our process is how we calculate the margin of error. We use basically the same formula. E equals something times our standard error of the mean. The something, though, is a t. We denote it by a variable t sub alpha over 2 instead of z sub alpha over 2. And what is this value t? It's this value t is called it's from the student t distribution. So let's see. So in order to get this t value, like before, we'll need to know the confidence or significance of the of our confidence interval, and we'll need to know something called the degrees of freedom, which I will denote by DOF, and it's actually very simple to calculate. It's the sample size minus 1. Now, if we do this old school, we'll just look it up from a table, and I don't plan to spend any time doing that. In our calculations, we'll wind up using scipy.stats.t.ppf to do it. An example of how we would do this is, say we have a problem where we have a sample with 27 elements in it. We calculate its mean to be 40.89. We calculate its standard deviation to be 4.09. Since it's a sample size of 27, we'll have 26 degrees of freedom. We'll use our S and our N to calculate the standard error of the mean. We will look up our T statistic. Since it is a 95% confidence, our T will be subscripted 0.025, right? You take your 0.05, you divide it by 2, and then you use 26 degrees of freedom, you get this. Then you multiply the t value times your standard error, and that'll give you your margin of error. Now, taking our x bar and subtracting the 1.62, we'll get the 39.27. Adding the 1.62, we'll get the 42.51, and this is our 95% confidence interval for the mean.